Okay, we are continuing. We're at question number 19. And most of these things are going to be solvings now. So I'm going to be going through them. We're going to talk through the steps. They say to start by adding 2 to both sides. Now, last time we subtracted 8 from both sides. This time we're going to add the 2x to both sides. Both ways will solve the equation. Last time we ended up with having to divide by -2 and I switched the way that the arrow points. Now, when I move the x, I don't have to change the way the arrow points because it moves the x to the other side anyway. So here's another way to do this so you don't have to worry about changing the direction of the arrow. So I'm going to add 2x to both sides like they told me to do. They literally say by first adding 2x to both sides. So I'm going to add 2x over here. Now remember, when I add or subtract x's, they cancel out. I have 2 x's, I take away 2 x's, that leaves literally nothing. The x disappears along with the 2. I end up with now what ends up happening is now I have to get rid of the 14 and the 2 here. I can do either, but I'm going to get rid of the 14 first. Generally speaking, it's best to add and subtract until we can't anymore when we're solving equations. That's backwards. It's kind of like the order of operations backwards. These we would 8 to -6. Are equal to 2x. Now I get rid of the 2 by dividing. The 2's cancel out, and I end up with -3. It's less than or equal to x. Now you'll notice that in the last one, we got the same answer. X is less than or equal to -3. -3 is greater than or equal to x. It's the same thing, just switched sides. The whole thing is flipped around left to right, right? It's pointing at the x. X is smaller than -3. Pointing at the x, x is smaller than -3. It's the same answer, but in one of them, we kept x on the left side, and it turned around the arrow to point the other way. On this one, we moved x to the right side so that it points toward the x. Both work. Gives the same answer, and I guarantee you that's the only thing. So here's what we're finding out is if I want this to make something bigger than 14, I need to put in some -3 or -4 or -5, anything less than -3. Why? Because I'll multiply times -2 and it'll make a big number that adds to 8 to be bigger than 14. That's what's going on. Okay, well, we're going to solve some of these. I'm going to give you a second. Please try to solve these on your own. Ask yourself, what will I do first? What will I do second? Did I get it right? It's okay to get these wrong, but it's very important you know what you did wrong. Okay? So I'm giving you a second for each of these, and then I'm going to solve them. We're ready? 5, 4, 3, 2, 1. Let's do this. We're going to solve the inequalities. First, I don't like parentheses, so I'm going to distribute like this. I'm going to end up with 4x minus 12. Because I multiply the 4 times the x and times the 3. Okay, so the next thing I need to do is I need to get rid of all of the things around the x. Right now, there's a 12 and a 4 with the x. I'm going to add first and then divide. I don't want to divide by the 4. You could divide everything by 4, but it's very easy to make a mistake there. So I'd prefer to add 12. This way works more often. It's more tried and true. So I'm going to have you do it. So that leaves me with nothing over here but a 4x. Now I have 12 plus 8 is 20. Okay, and now I just need to get rid of the 4 by dividing. I get x is less than 5. And again, that's going to say if I plug in something less than 5 for x here, like 4 or 3 or 2 or 1 or 0 or 1, -1 or -10 or -100, anything less than 5 will make this end up being less than 8. It'll make the left side of the equation be less than 8. That's what we just figured out. Okay, this one over here. Again, I don't like the parentheses, so I'm going to get rid of them. I'm going to zoom in a tiny bit too, because it feels a little cramped writing there. Okay, so in fact, I'm also going to change the color. I don't like the red. The red makes you feel like something's going to happen. Like red alert in Star Trek. Okay, -3x and -24. 2x and 6. Here we have our equation only with no parentheses. Now I need to get rid of some x's from each side. Now I could put x's on that side and have a bunch of negative x's, or I can put x's on that side and have positive x's. I'm going to choose positive x's. I'm going to get rid of the negative x's. There are 3 x's over here, -3x, and 2 x's on that side. I'm going to get rid of the -3x by adding 3 x's. The first step you always want to do when you have x's on both sides of an equation is find a way to get rid of all the x's on one side. That's your goal. Now, I could have gotten rid of the 2x instead, but I don't like getting rid of the 3x. This guy's gone now. So now I have just a -24 on the left side. Notice I added to get rid of it. That gets rid of the x's along with the numbers that they're attached to. 5x plus 6. Okay, so now I need to get rid of this 6. I'm going to subtract the 6. Subtract the 6. It's going to give me -30. It's going to be -30 is greater than or equal to 5x. Finally, I'm going to get rid of the 5. Oh, I got to cancel out some things too. Cancel out the 6's, cancel out the 5's. Notice when I divide, that does leave the x there. So when I want to get rid of a number that's next to an x, I divide to get rid of it. If I want to get rid of the number and the x, like here, then I subtract or add. Okay, so now we've got 30 divided by 5 is -6, by the way. Oops, that's going to be, change the color back to black. And there we go. Another page done. Let's see what's over here. Notice these pages are all the same stuff. Here's what I look at these. When I see these, I see x is right here. It's all alone. There's no x on the other side. So all I have to do is get rid of the 2 and the 5. Ask yourself, how am I going to get rid of the 2 and the 5? 5, 4, 3, 2, 1. All right. You had your chance. I'm going to get rid of the 2 and the 5. Oops, Control Z. I'm going to get rid of the 5 first. That's going to leave me with 2x over here. And 11 minus 5 is 6. I'm going to get rid of the 2 by dividing. The way I know what to do, I do the opposite of what's happening to x. X is being added to 5 and is being multiplied by 2. We learned inverse operations. So if I want to get rid of a plus, I have a minus. I subtract 5 and it cancels out. If I want to get rid of multiplication, I divide by 2 and it cancels out. That's the trick. You just do the opposite of what's happening to x. And eventually, nothing's left but the x. So think about that with the next one over here. What is happening to x? And what can we do about it? This one's a little tricky because that minus sign messes with our brain a little bit. But That's the only trick. Other than that, it's just like the other one. The minus is confusing because it goes with the 3. Minuses always go with the number after them. They don't go with the 7. A 7 is a plus. It's a positive 7. So if I want to get rid of the 7, I need to do the opposite of plus. I need to subtract 7 from each side. Minus 7. Minus 7. I'm going to get rid of this 7. All that's left is a negative 3. The negative goes with the number to its right, always. Okay, and 22 minus 7 is 15. I want to get rid of negative 3, so I'm going to divide by negative 3. What did we learn about dividing by a negative? We have to turn this around. I'm going to write it in red. When I divide by a negative 3, I have to turn the arrow around. So these cancel out. And with x, oops, are equal to negative 5. I put it in red. You don't have to put it in red, but you have to remember to always turn it around if you multiply or divide by a negative. That's the big rule with inequalities. Everything else is the same as what you've learned before with equalities, with equal signs, with equations. Okay, so this one has the parentheses to get rid of, and it's going to have some extra numbers, so think about it. Solve it, and then you can double check what I did. Here we go. I would distribute. Notice that's a negative 2. This is a negative 2. Negatives go with the number after them. So I'm going to have negative 2 times x and negative 2 times negative 4. But up here in the front is a 6 that never gets touched at all. So I have 6, negative 2x, and positive 8. Greater than or equal to 8. Notice a negative 2 times a negative 4 makes a positive 8. That's why it's positive. Okay, so now I'm going to put these guys together. 6 plus 8 is 14. Remember, that's the commutative property of addition. It says it doesn't matter what order I add them in, as long as I add them together eventually. Almost there. Okay, so now let's get rid of this 14. And that goes away. And I end up with negative 2x greater than or equal to 8 minus 14 is 6. Whew. And so I want to get rid of the negative 2, so I'm going to divide by negative 2. And I'm going to, there's even more. And I want to get rid of the 6. Well, I don't want to get rid of the 6, but I have to do the same thing to it that I did on the left. This cancels out. And you may remember, I just divided by a negative, so what do I have to do? You guessed it, I have to turn the arrow around. Turn the arrow around. Homework. Okay, so remember that. Okay, let's do the next one. Here it is. What would you do? Well, let's see here. I need to get rid of the fraction. I can do the fraction actually, but I can also, once I get rid of the parentheses, then I go on. I'm going to do a different thing to get rid of the parentheses or the fraction, because I think it's a useful thing to know. You can multiply 4/3 times 6 and 4/3 times 9, and you'll get a nice answer. But generally speaking, that doesn't work, because this number doesn't always go into both of those nicely. So a way that we can get rid of that fraction if we don't want it is we can multiply everything times 3. So I'm going to have 3 times this. And 3 times that. Now notice the thing on the left side, the whole left side is being multiplied together. Even though there's an addition in here, I just have to multiply the whole thing by 3 because that's within parentheses. So this is really just multiplication and division. And the order of operations says I can do this multiplication first. 3 divided by 3 makes 1, and it cancels out. So I end up with 4 times 6x minus 9 greater than, greater than negative 30. Okay, so there's the equation or inequality. Now I can get rid of the thing. The nice thing is I got rid of the parentheses. It's nice. It's great. So now I'm going to distribute like so. I'm going to get 4 times 6 is 24. 4 times 9 is 36. Negative 9 is negative 36. Getting there. Next, I need to get rid of this negative 36, don't I? I need to add 36 to each side. This guy cancels out. So now I have 24x greater than or equal to 6, because 36 minus 30, that makes 6. Okay, finally, I got to get rid of this 24 by dividing. We have to do the same thing to the other side. X equals 6/24. Now, technically, that's not a simplified fraction. What do I need to do to simplify that? Well, I need to find out what goes into both of them. 6 does. That's really just 1/4. Oops, I said equals. Let me fix that. Very easy for me as a teacher. I do this all the time because I've written a lot of these problems and I've done a lot of these problems in my lifetime. So I just get used to doing equations and then I just start writing equals for no reason. One thing is technically I can't say this is greater than 1/4. I'm going to say, I can do a comma here, I suppose. Or you do equals, because this equals that, not greater than that. These are the same number. It's a simplified fraction, right? So I could go like this. Okay. Let's see here. Almost done with this page. Zooming out a little bit. Where are we at? Oops, wrong way. Oops. There is one more. Okay, let's get rid of this one. And then we'll go on and on and on and on. This one is a long assignment. So this one has fractions as well. Notice it has a 3 and a 6. So what I can do is I can multiply to get rid of fractions always. This is called clearing fractions. I can look at it and say, hey, I want to get rid of the 3 and the 6. I'm going to multiply by 1 or 2 of those numbers. Now, I'm going to tell you, if I multiply by 6, 6 is 2 times 3, so it's going to include a 3. Okay, so I'm going to multiply by the bigger number because this guy goes into that guy. And you'll see why that matters in a moment. So I'm going to multiply everything times 6. Zooming in a little bit more. 6 times this, and this times 6. Okay, I'm going to get, let me just write it really quickly. 6 times 2 is 12. So that's going to be 12 over 3. X plus 5. Now I could pick any number to multiply by both sides of the equation. The reason I'm picking 6 is because when we multiply 6 and we divide 3 into 6, I get 2. They cancel out. And 6 also goes into 6. It's going to cancel out and make 1. I'm going to write 6 times 5 is 30 divided by 6. I made everything 6 times as big. Now I don't have to worry about the things in the parentheses because they're already being multiplied by this number. So if they were being added to this number, I'd have to include them. But because they're just being multiplied already, you don't have to multiply by this and by the 6 separately. No, because the 6 and the 5 combine to make 30. So technically I am still going to multiply them by the 6. So don't have to worry about what's in the parentheses. As long as things are just being multiplied, you don't have to multiply each of the numbers, like the 5 and the 2 and the x and the 8. No. Okay? Just once times the whole thing. Okay, so the nice thing about this, here we are. This becomes 12. 12 divided by 3 is 4. And 30 divided by 6 is 5. Cool thing about this is I just rewrote the entire equation. This is the same equation as the beginning, but I don't have any more fractions. All right? These 6's canceled out and left a 5. These 6 canceled out with a 3, and then there was a 2 left over to multiply, and I got 4. So there are lots of ways to think about it, but yes, now I don't have fractions. That's a very important skill for later because you deal with fractions, my friends. Fractions are not going anywhere. But we can solve any equation with fractions by just getting rid of them the first step, like that. Okay, so now I got to distribute and solve. 4x plus 20 less than 5 times 2 is 10x minus 40. There. All right, so we have nice numbers. I want to get rid of some of these x's. I'm going to get rid of 4x's over here. But I have to get rid of 4x's on the other side as well. It's gone, which leaves me with a 20. 6x minus 40 plus 40. Now I need to get rid of the 40 and the 6. So I'm going to get rid of the 40. I hope you can see. I know I'm going faster than you would. But once we get the hang of this, we can solve things very quickly. If I had a pencil, I could go faster. Divide by 6, and we get 10. Notice I did not divide by negatives, so I can just say 10 less than x. I don't have to turn that arrow around. That inequality pointing the other way. It just stays the same way because I never multiplied by negative, and I never divided by negative. Hooray! Wow, this takes a while, doesn't it? Okay, let's do this one and then I'll take another short break, I think. The biology club plans to sell plants at a fundraiser. They found a supplier that charges $25 delivery fee plus $8 per plant, but the entire bill will be paid in advance. Okay, they have $475 in savings account. We want to find out. Just say they can spend no more than $475 on plants. Okay. First, I have to make a formula using the $25 and the $8 per plant. It would be like this. Cost is $25, $8 per plant. And there we are. We have a formula for the cost. And then we can also, let's see, that's what I really wanted. We can also say, well, we know that the cost has to be $475, right? So we could say I know that the cost will be 475, right? Equals 25 plus HP. That's not exactly what they said. They want us to spend no more. So we can spend less than 475. This cost can be less than 475. Just can't be more. So really what we want is we want to have the 475. Yeah. But that's the most it could possibly be. The cost has to be smaller than 475 or equal to. And there we go. That's what it looks like. All right. We use substitution to determine whether the club has enough money for 50 plants. Let's find out. We're going to take this and put it down there. We're going to say, well, for 50 plants, right? 475 should be more than or equal to 25 plus 8 times 50. Well, if you know 8 times 5 is 40, you know that 8 times 50 is 400. 400 plus 25 is 425, but we want it to be less than 475. Is it? Is 475 bigger than 425? I sure hope it is. Yep. So what does that mean? That means that it would only cost $425 to order 50 plants, so they have enough money. In other words, the cost is less than 475. They have enough money. They will have $50 left over, right? Okay, let's use substitution to see if a 100 works. Okay, great. 475 greater than or equal to 25 plus 8 times 100. 8 times 100 is 800. Plus 25 is 825. Clearly, that is not a good thing. Is 475 bigger than 825? No, it's not. In other words, nope. This costs 825. That is $20 too much. Let's see, 400, 350 for budget. Solve the inequality. 25 plus AP equals X less than that. Notice that's what we wrote, only it's backwards. 475 is greater than 25 plus AP. This is 25 plus AP is less than 25. It's the same thing, just backwards. Solve it on your calculator. Record your calculator table as part of your solution. We're going to solve it on Desmos. How do we do that? We graph each of these. This equals Y, and that equals Y. I'm going to write Y equals 475. And the other one is 25 plus 8p, or 8x. We'll use 8x. There we go. Let's see where we end up. This is our cost going up and up and up and up. This is what we want. This is our ceiling. We can't spend more than this, 475. So this is where we hit $475. Looks like we can't buy 100, 10, 20, 40, 60, 80. That's going to be close to 60, somewhere between 50 and 60. 56.25. Can I buy 56 and a quarter plants? No. I can only buy 56. So I'll be just under $475 if I buy 56 plants. I'll be exactly, if I could buy an extra quarter of a plant, then I could spend exactly $475, but I can't. And that's okay. So let's go in here and we'll say, actually I'll go like this. I'll say, I can go, how do I do it? I can do this. Whatever. We can just say that for 56.25, 56.25, 56.25. I used Desmos. Hit the lines across that. $56.25. A point. In other words, 56.25 plants. And that's how you do it. You can buy up to 56 plants, but no more because you can only buy a quarter of a plant more, and that doesn't make any sense. Check the solution to the inequality using a graph calculator. Yeah, we just check it on Desmos. And answer the following questions about the statement. X is less than -1 or X is greater than 4. Complete the table by determining whether the given values of X make the statement true. Okay. If X were -4, would that be less than or greater than 4? Here we'll say, we'll type it in. X is less than 4. Why? Because -4 is less than 4. How about -2? X is still less than 4. We're agreeing so far. 0. 0 is also less than 4. Well, pi. Is pi less than 4? Yep. Pi is 3.14. That's less than 4. Now, why am I saying X instead of pi? Because they're saying right here, these are what X is. X is this number. So I can say, since X is pi, then X is less than 4. Yeah, pi is less than 4. That's why I know X is less than 4. 7? 7 is bigger than 4, so I'm going to say X is greater than. And 12? 12 is also greater than 4. We have to write. Pretty easy, right? I have additional numbers that make this true. Wait, what true? Oh, darn it. I get it. I've messed up. I misread this whole thing. Darn it. Let me erase this. Okay, so let's graph this really quickly so we understand what we're looking at here. Here's 4. Here's -1. right? X is less than -1. So I want numbers less than -1. Or I could also have numbers greater than 4. Sorry, I completely misunderstood. So in other words, I want all of the numbers that are not between -1 and 4. So is this true? Does 4 satisfy that? Is -4 a number that's less than -1 or greater than 4? Yeah, 4 is down here, so it's on this line, right? So -4, yes, that's what I wanted to write. -2, is -2 less than -1? Yeah, it's right here. It's in the filled in area. Yes. How about 0? Notice 0 is not below -1 and it's not above 4. It's somewhere in the no man's land here. We don't like that. That's not what we want. So no, we only want numbers that are less than 1, -1, or greater than -4. How about pi? Pi is still not big enough. No. How about 7? 7? Now we're greater than 4 like we're supposed to be. So just to understand, this right here is up here. And no, okay, that's what we're referring to. It should be in italics so you can see it better. Now we've got numbers that are greater than 4. Greater than 4 is okay, yes. And yes. Okay, we're going to list 5 other numbers that make this true. Well, we just need numbers less than 1, -1, or greater than 4. So how about 100? That's greater than 4. How about -1,000? That works. How about -pi? Sure, that's a negative. It's less than -1. How about 15? How about 27? There are lots of anything less than -1 or 4. That's it. Okay. There's tons and tons of numbers we could pick. Okay, construct a graph on the number line to show all of the numbers that make the statement in question 23 true. Oh, we just did that, didn't we? I just made it right here. So we want all of the numbers that are less than 1 or greater than 4. So that means I have to start at -1 here. And I need to mark all of the numbers that are less than that. Make this slightly thicker so we can see it. I'll make it red too, because why not? And it'll be really obvious. There we are. And then 4 is right here. Oh, you know what? I started at -2, not -1. I'll fix that in a moment. And the last thing we need to do is make sure when it says less than, does that mean, does -1 work? Is -1 less than -1? No, it's not. It's equal to. So it doesn't say it can't, it's allowed to be. It has to be less than. So it can't be -1 and it can't be 4. It has to be greater than. So what we're going to do is we're going to Control Z. Actually, no, I'll go down here. I'll erase this a little fast. That one's a little crooked anyway, right? Okay, and I need to really quickly zoom in. We need to make some fancy and dangled circles here that look like this. And this. Why do I need to do that, you may ask? You may remember the empty circle means that it's not allowed to be that number. We can only have numbers less than -1. We can't actually have -1. It doesn't say that. It says less than -1. So I make a graph that doesn't include -1, just numbers less than -1. I'm not going to fill in -1 itself. Okay, and let's see. Now we're going to just make -1. That's going to be this chunk. I'll be able to even do this. I was going to. Apparently it doesn't like that. Well, one more try. That worked. Okay, I'm going to set these guys up again. Now, which half has to do with being less than -1? Well, this half, right? So the property where it says x is less than -1, that's the left side of this graph. Or it has to do with x being more than 4, it's the right half of the graph. That's what we end up having. And when I put them together, I get this. Could you use graphs 24 and B? All I have to do is combine them, right? B and C combined makes A. That's all they're asking here. The two bottom graphs combined forms the top graph. All right, zooming out. We are okay. All right, getting there. A few more pages left. Okay, now we need to have numbers that are greater than 2, -2, and less than 7. Now this is a very important word, or and, okay? It doesn't even actually say anything. Or means, in math, it means that 1/4 So and means both statements have to be true at once. So I have, the first one had an or in the middle, and so I just had to find numbers that were less than 1 or bigger than the other. Here it says and, so I need to find something that's greater than this and less than 7 at the same time. Okay, so -4, it's less than 7, but it's not greater than -2, is it? No, so it doesn't count. It has to be both at once when it says and. Nope. What -2? Well, -2 is less than 7, but it's not greater than -2. It's equal to -2, so that doesn't count. How about 0? 0 is bigger than -2. 0 is less than 7. It's both. That's what I want. I want a number that's both of those things at once. How about pi? Pi is greater than -2. It's less than 7. Yes, that works. 7 is greater than -2, but it's not less than 7. It's equal to 7, so that's a no. 12, greater than -2, but not less than 7, so it's a no as well. So it's the middle ones that work. 5 additional numbers. We're just looking for numbers bigger than -2 and 7. So let's go with, just to be simple, -1, 1, 2, 3, 4, and 5. There, those are numbers greater than -2 and less than 7. Okay, we're going to construct a graph again. This time, we want to find all the numbers greater than -2 and less than 7. Here's my -2. It says, it doesn't say I'm allowed to be -2, so I'm going to zoom in really fast. I'm going to make that circle around -2. Oops, with a slightly less thick marker. -2. And 7. Now, I want all of the numbers that are greater than negative 2 and less than 7. All of the numbers greater than negative 2 are this way, right? And it would go on forever, but then if then I'm not less than 7, right? And all the numbers less than 7 would go this way, but then I'm not greater than negative 2 if I go past here. So really, these guys are borders. All I really need to do is fill this in like here. And now I have all the numbers between negative 2 and 7. Those are the ones that are both greater than negative 2 and less than 7. So how does this look? I'm going to do this again. This is going to be easier to just make happen. Here's negative 2. And here's all the numbers greater than negative 2. Oops. Out of mouse pad. Those are all the things greater than negative 2. X greater than negative 2. And 7, well, you know what to do. All I have to do is mark the 7 really fast. We'll make sure that I'm not equal to 7. And from there, it's just a matter of filling in all of the numbers less than 7, like so. And there you go. How would I think about this? Notice and is where these two are both existing, where they overlap. I can't just say combine them two because this goes off forever in one direction, that goes in the other direction. It would go include all of the numbers. It's just where they overlap. The bottom graph is where is filled in where the top two graphs overlap. There you go. It's true. And that's going to be true for basically all and type of graphs that you have. This is called a compound inequality. Compound means to combine two things or more. That's all. So a compound inequality combines two inequalities. Like x is bigger than one thing and x is less than another thing. Those are two inequalities. The difference now is we're just going to write the inequalities with numbers. Here's an inequality and there's an inequality. Okay, so we have to write them with numbers. And now I just have to solve them. It's really hard to figure out what this x is and what that x is, right? But if I just can simplify it and write x is bigger than this number or less than that number, then it's going to be a lot easier to graph. So that's what we're going to do. We're going to solve each of these. And we're going to figure out what numbers x is greater than or less than. So I'm going to solve them separately. I'm going to treat them like two completely separate things. So I'm going to add 10 to both sides of this. And I'm going to end up with 3x less than 21. Then I'm going to divide by 3. This is going to cancel out. I'm going to get x less than 7. Hey, that I can work with. Now I got to do the other side separately. I need to get rid of the 5, minus 5, minus 5. So I'm going to end up with negative 2x is less than 4. Now I need to get rid of the negative 2, so I'm going to divide by negative 2, which remember, that means I have to switch the order, the way that the arrow points. Arrow points the other way now. And there we go. I need x to be less than 7 or greater than negative 2. Anything less than 7 or greater than negative 2. So that's just the combination of the two graphs. What does that look like? So any numbers that are less than 7, let's do that one first. I'll make this one be purple. That's all the numbers where x is less than 7. Now I'm going to pick another color for x being greater than -2. X greater than -2 is going to look like this. Now remember, or means one or the other is true. As long as one of them is true, I don't really care which one. So I just have to pick any number that satisfies either of these. So say the number 15. Well, 15 is not less than 7, but it's greater than -2, so it works. 0 is both. It's less than 7 and greater than -2. -10, it's not greater than -2, but it's less than 7, so it works. So this particular problem, it counts for all the numbers, even -2. Of course, it doesn't work for being greater than -2, but it's less than 7. Everything on the graph is filled in by one or the other. And that's all we're asking. One or the other is true. So this, literally every x works in here. Every x is going to either make this true or that. You can pick any number you want, and it'll either make this one work or that one. We're going to talk about that more in class. Okay. Solve the compound inequality. We're getting close. We're at the last 2 pages. Hooray. Solve the compound inequality. 7 is minus x is greater than 10. And that. And. Remember, this is and. Okay, so let's do it. Let's solve this thing. I'm going to solve this in red. I'm going to change back to a 1. 1 was kind of nice. I'm going to zoom in a little bit. Let's do this. Okay, so I'm going to get rid of, you know what? I'm going to add x to both sides because I feel like it. You don't have to do this. This gets rid of the negative x. This cancels out, and I have 7 is greater than 10 plus x. Now I get rid of the 10. I end up with -3 is greater than x. Here we have it. How about this one right here? I need to get rid of the 9. So I'm going to add 9 to both sides. 9. I'm going to leave me with a 4x over here and an 8 over here. Oh, this is terrible. I'm not writing very well. Let me fix it a little bit. I get rid of the 4. 4. Get rid of that. X is greater than or equal to 2. So I've got those 2 numbers. Okay. In the last graph with 4, just to be absolutely clear, absolutely every x Okay, so this one had infinitely many solutions. X could be anything. This one, and is a lot pickier. So we'll see what we end up with here. Going back to text, switching, no, not the text, switching this to figure out. We're going to do this one in green. This one's going to be in green. It's going to be -3 is greater than x. -3 is greater than x. So I'm going to find -3 here. I'm going to fill it in kind of. -3 is greater than x. So I need to fill it in things greater than x. right? And now it says x is greater than 2. X is greater than 2. I'll do that one in purple. Here's 2. Greater than or equal to 2, isn't it? I'm going to put a little dot here. So when we say and, we're looking for where they overlap. Right? So this one up here, the actual solution, x is this or that, infinitely many solutions. Why? Because x could be any number. Or you could even say x can be all real numbers. Okay? But down here, you have x has to be where they're both exact. So it could be 2 or 3 or 4, anywhere where they're both at, where they overlap. So any number bigger than 2. So the solution is x is greater than or equal to 2. Solution, because I graphed it to see. That's where they overlap. Okay, that's how that works. Okay, 2 or 3 more problems. Let's do this. Oh, a show choir. I love a good show choir. The show choir at musical high school has been raising money to pay for a trip to New York. Great. They need $180 to pay for their trip, so they decided to sell candy bars. Great idea. They'll pay a $100 setup fee for the candy bars, and then they can sell them each for $2. Unfortunately, the principal told them that they cannot raise more than $500, or else they will have to pay taxes on their profit. That is hogwash. It's not a real thing, but that's okay. Write a compound inequality to describe the situation. Okay. So what is going on? Well, we know that the amount they raise, x has to be less than 500. We know that for sure. We're going to say, let x equal the, or just say equal like this, equal the amount of money they raise. Okay, so this is one thing we know for sure. They can't raise more than $500. Oh, more than. So technically, it can equal $500, just no more. Okay. All right, and now we're going to find the other part. They got this $180. They need $180, and they pay $100, but they sell for $2. So they need, let's see, the $100 that they pay. So $2 per candy bar. Well, you know what? We'll say $2 per candy bar. We're going to get there. Candy bars is our variables, not the money they raise. We'll get to the money they raise. 2 candy bars minus the $100 that they have to pay to get the candy bars in the first place must be greater than 180. Otherwise, they can't go on their trip. Would you agree? Okay, very good. However, let me fix this thing. I made a mistake. Get rid of that. Get rid of that. We're going to say C equals the number of candy bars we sell. That's what we're going to keep track of because that's the actual variable. My bad, folks. Okay, the other thing we know is that the number of candy bars they sell, the 2C minus 100 has to be less. They can't less than or equal to to $500. Okay. We're going to have a little bit of fun with this actually, because I like messing around with stuff. So we're going to solve both of these at once. Are you ready for some fun? We're going to write 2c. Well, actually, 180 is the least they have to make, right? It has to be less than 2c minus 100, which has to be less than or equal to 500. Let me write in the less than or equal to's so you can see what I'm looking at here. Let me write them thinner so that they're actually legible. And that's our equation. Notice it's got two things in it. This is only allowed with inequalities and only, well, yeah, there are situations where it doesn't work this way, but we're going to solve it this way. We're going to get c by itself. How do we do that? Just like we did in previous ones, we got to get rid of the 100 and the 2. So let's mess around with this and see how it looks. Okay. Let's get rid of the 100 by adding 100 to both sides. So I'm going to change it to black. Plus 100. Now here's the weird thing. There are not two sides now. There's the middle, and then there's the right side. And there's the left side. For 3 different parts. And so I have to keep track of all 3. And that's kind of fun. 280 over here. Less than. All that's left in the middle now is 2c because the hundreds canceled out, didn't they? And over here we have 600. Okay. So what does that mean? Well, let's divide everything by 2. Middle one and both sides. That's going to give me 140 over here. That's going to give me just c in the middle. And that's going to give me 300 on the right side. Now remember, C stands for the number of candy bars they sell. This is how they get money. They pay $100 and then they sell the candy bars for $2 a piece. If they sell 50 candy bars, they break even. If they sell more, they start making money. They're not allowed to make more. Well, they have to make more than $180. And they can't make more than $500. So figuring out from this, it says C has to be between 140 and 300, which means they need to sell 140 to 300. That's all. But we just figured out C has to be in that range. Now, if we're graphing that, we would make a graph that's in between those. Okay, we're going to graph this one. And, okay, I'm going to solve this, and then we're going to do the babysitting, and we're done. Great. If we had time, I might make you do some of these and talk about them in class, but we're catching up right now, and that's okay. Let's solve this. We're going to solve them separately. So that means this guy, we're going to solve first -7, -7. Oops, I do not mean to write that thing in the middle. To get rid of both of the 7s. So I'll have -5x greater than 0. I divide by 5, -5. And 0 divided by a number is just 0. These guys canceled out though. And I end up with x. The arrow has to point the other way. So that's one of my statements. When I solve it, I get x has to be less than 0. X has to be a negative number. That's it, just a negative number. That doesn't make sense, actually. it works. Never mind. I changed my mind. Okay, because, yep, a negative number times a negative number is going to make a positive number. And then it'll add to 7, and it'll be bigger than 7. Okay, over here we've got, let's see, I'm gonna add an x because I feel like it. Add x. That's going to give me 3 less than or equal to negative 1 plus x. Now I need to get rid of the negative 1s. The x is alone. I'm going to add a 1. I get 4 less than or equal to x. That's how it's done, my friend. Okay. So what does that look like? We need and, right? We need where these overlap. So x has to be less than 0. It's going to go that way from 0. X also has to be less than 4, less than or equal to 4. Where is that the same for both of them? Well, this one keeps going and they overlap. So the place where it's the same for both of them is where things are less than or equal to 0, because it can't even be 0. Why? Because if x was 0, it wouldn't satisfy this guy. X has to literally be less than 0. So we're going to do that. We're going to make x be less than 0. We're going to go like so. Boom. There we are. That's what we want. Yay, almost there, my friend. I'm going to erase the other things because they were just for thinking. There. X is less than 0. All right. Maggie charges $15 an hour for babysitting. Great. She wants to make $105 this weekend so she can buy a new bag for school. She does not want to make more than $195. Why? Because she'll have to pay taxes. I'm sorry, that's another bogus one. You can make $200 in babysitting and not pay taxes as a minor. You're going to be all right. What are the possible numbers of hours Maggie can babysit this week to make enough money for the bag she wants to buy without having to pay taxes on her earrings? That's really odd. Earnings, sorry, not earrings. That would be even weirder. Okay, so here we go. Clearly, the number of hours she works is what earns her money, right? So we're going to make our variable be h equals hours she works. And she's trying to figure out how many hours do I need to work then, right? So she wants to earn $105, right? At least. Maybe more, but certainly at least. So she makes $15 an hour. $15 per times every hour needs to be at least 105. But it can't be more than 195. She does not want to make more than that. So let me write in these things really fast. We're not on 4 anymore. We're on 1. And we want to make more than 105 at least, right? It could be 105, but ideally it's more, right? At least. Okay. However, she cannot make more than 195. It can be exactly 195, but no more. Okay, so this is our inequality. Notice we have another one where h is in the middle between these things. We have these rules that are keeping us from being too high or too low. So I can write this as an equation again as one big long one. I can say 105 is less than or equal to 15h. Notice that's the top of our two things, right? And then the bottom one is the rest of my statement, 195. So in other words, we want to work a number of hours so that I make between $105 and $195. How do I solve this? Well, I just divide by 15, don't I? I divide both sides by 15, or all three things by 15. Then I'll get an answer. What is each of these divided by 15? I'm just going to type in 105 divided by 15 is 7. 195 divided by 15 is 13. There it is. 7 and 13. Great. That's what I'm going to type in here. 7 is 105 divided by 15. These canceled out, so I just have H. And 13 is 195 divided by 15. In other words, she needs to work 7 to 15 hours. That's the trick. Yay, we did it, my friends. That was a long, horrendous assignment. All 13 pages. Good luck.